decision makers in this realm, plus, of course, universities. Why I am here? I am here actually to give an overview of the research related to phosphate. I use the terminology phosphate-related research. Of course, there's a lot of angles, perspective of this research, but I divided into 4 main categories. I'm sure you can point out more categories, but just to give an example to see the dynamics and to see the key players in terms of governments, research institutes, nations, etc. We have, of course, a couple of products which actually helps us along the way of doing this. Basically, I was using Web of Science, also Insights, which is a tool built on top of Web of Science to analyze and benchmark the research. So as a Clarivate Analytics, we actually we think that the whole cycle, the life cycle of innovation worldwide is some intersection of 3 circles. The first circle is discovery, which we in the Arab region or in MENA region are very good at it, actually. We are very good in research or discovery in itself. But are we doing that well also in protection? In the protection process of this research, I mean patents. What about the commercialization of the results itself? If we manage to find an intersection between these 3 circles, then we should be fine. This is the life cycle of innovation. Actually, this is the logo of Clarivate Analytics taken from this part. So clients, I mean, worldwide, we have like Microsoft, Sanofi, Philips, Pfizer, etc. 49 of the top 50 pharmaceutical companies are our clients worldwide. So if you steal from one author, it's plagiarism. If you steal from many, it's research. It's our secret. We keep it for ourselves. But basically, if you want to do research, you don't want to go and reinvent the wheel. You should see what people are doing actually, and then get on top of this to build your ideas. So for the agenda for today, first I will start speaking about why research matters for nations, for any kind of entities, tools and techniques for innovation, global research patents on phosphate, and then I will take like a showcase about Moroccan research on phosphate to see where, what is the status there exactly. And then I will end up, of course, with conclusions and outlooks. Why research matters? This is a slide showing here the top 10 nations in terms of GDP, talking about economy, in 2017. You can see the nations, okay? US leading. On the right side, you will see also top 10 nations in terms of research output, the amount of publications in research in every kind of research area in research overall. Let's see how does it compare. So we see that also the States is leading in terms of research. Second place, China. Then comes Japan, which appears here in 3rd place. So here it appears in 4th place. Germany equals even up. The UK, India, France. So Brazil, which appears here, like in 8th place in terms of GDP, it's in ranked 13 in terms of research output. And then we have Italy, Canada, Spain. What about Spain, which appears number 10 in terms of research output? It's ranked 14 here. I think the conclusion is there, or? So this is like quite a correlation between economy and research. So this is a way to say whatever, I will not start the debate what's leading what, actually. But then if you are good in research, you are good in economy. This is a key message should be actually conveyed to the governments, decision makers, that doing research is not something, it's like, not like a makeup or so. It's something extremely important for nations. So basically, GDP and research, economics dynamics are, to a large extent, research dynamics. They are the same, basically, as we have seen. Tools and techniques for innovation. What's the idea of Web of Science? This is like a product which has been around since tens of years. What's the idea there? So because I'm pretty sure that you are researchers, but some of you maybe does not have or really have a vague idea about the ISI, the Web of Science, the citation analysis, this kind of things. So if you want to, in the past day, in the old days, if you want to find something, you really have to search for data. There's a rare of scarce of data. But nowadays, it's like finding something in a pile of grass or so. So the challenge shifted. There's still a challenge, but because now we are overwhelmed with data. So shifted from finding the paper towards finding the right paper. You still have to be efficient. You're still facing challenges, but it just shifted. Of course, because of Google and Google-wise search engine. So if you are a researcher working in a realm like water treatment here, if you type in Google, you will find like more than 6 million results. If you even use Google Scholar, you will end up with 420,000 results. For a researcher to go through like 6 million or 400,000 results, this is a lot, or? It's not efficient. And I'm pretty sure the kind of data you will get, it's not really encouraging. So one of the results we've got from Google is only a photo of this thing, can use in marketing some stuff. Google Scholar, it can show you actually similar stuff. So this is the idea. For a researcher, you need data, but you need relevant data. So Eugene Garfield came up with this idea of building a database, citation database, linking science not through category, because all over the place, multidisciplinary publications or science is growing, and then sticking to the old category, subject category thing will not work because you have more and more articles and publications just not really belonging to one single category, but linking between two or more disciplinaries. It's the era of multidisciplinary, we all know this. So the thing evaluated from ISI, then Thomson Reuters, and now we are a standalone company, Clarivate Analytics. So you all the time have the choice between quantity and equality, but you need such indicator. As my kind presenter, professor, was telling, actually, so we can end up with some indicators, which is key parameters used by governments, by universities, by funding agencies in order to evaluate the kind of research output in terms of quality and quantity as well. So we have like sort of a editorial team picking up some journals to include in the database, because you don't want all the kind of research published in the world to be included in your database, because there's some journals are not really good enough to be included. Some of them, they are not peer-reviewed. And I'm sure that all of you have heard some weird story about journals publishing things which is by themselves weird. You don't need this in your database. It's a waste of time, it's a waste of man hours and everything else. So we have a committee which select and deselect journals to be included, just to make sure that you have top quality journals, offering you relevant research articles. So the citation itself, it's a linking between the present time, the future, because you would find who cited this work, and the past, because you will find out this article, which is good for you, which is relevant to your work, what kind of reference it's cited. And this is like building a net of citations. This is your road toward discovering more and more about the proximity of the topic. So let's start with the global research and patents also in phosphate globally. So we know that top 10 nations in phosphate reserves, it's, of course, Morocco with more than 70%. I know this number is debatable. It's a bit modest, but yeah, it's there. 70% of the, this is like more than around 50 billion tons. This is the reservoir. Of course, when I'm showing this, it means that the kind of like Morocco having 70% of the reserves, of phosphate reserves in the world, it should translate somehow to the kind of research being done in this realm in Morocco. Let's see. So these are the top nations, phosphate mining production by country, leading by China and then USA and then Morocco, of course. So this is the kind of funds thrown in research and development worldwide. So this is the number here is 400 billion. The number here was taken 1.4 trillion by 2012, and it's expected to be 2.3 trillion by 2030. Actually, it's underestimating the value because nowadays we know in 2017, 2 trillions were spent in research all over the world. So there's a lot of money to be spent in research. This is obvious. And the increase, average annual increase is 20%. This is really amazing, I would say. So number of phosphate-related documents indexed in Web of Science, the last 10 years. I mean, the time span I took from 2008 to 2017, I wouldn't include 2018 because it's ongoing. So you can see the number of publications from 2008 worldwide to 2017 is really increasing. It means that people are interested more and more in research related to phosphate. So here's showing top 10 research entities in terms of the number of phosphate-related publications. Also, last 10 years. We can see that 2 of them, they are Chinese, and the leading entity is Chinese Academy of Sciences, and then 4 of them of the top 10 are Americans. This can give you already a glimpse about the nations like China and USA actually are leading in this field. We are going to dig more and discover in terms of research area, are they actually leading? Let's see. So if we say, okay, we need research on phosphate, but something which have like agriculture approach, because phosphate itself, you can actually you can go and do research in terms of material sciences, in terms of the chemistry or geology, mining, environmental approaches. But here we are talking about agriculture. We can see that China is leading, and USA is number 2, and then Germany, etc., in terms of the number of documents in the last 10 years. This is what we call CNCI impact, because this is a a quantity indicator. This is a quality indicator. So CNCI is like category normalized citation impact. It means that we know if you are a mathematician working with mathematics in research, you wouldn't get a lot of citations. If you are working in pharmaceutical, you would get a lot of citations. It's irrelevant, you know, about your quality or the kind of impact you are leaving on the research community. So we normalize everything worldwide. So this is normalized in this research area, agriculture. It means that if China managed to get 1.35, it means that it's 1.35 of the world average. It's beating the world average by 35%, exceeding the world average. Of course, if you get more greater CNCI, it means that you are leaving greater impact. It's a quality indicator. Actually, it's one of the most important and relevant quality indicator which people use, and we also use for evaluation of science. You can see easily that UK is producing actually research with 1.87 CNCI. So it's more than the universal or global standard by 87%. The other nations actually are comparable more or less. So if we talk about also another quality indicator, which is a percentage of highly cited papers, which are papers lying on their category on the top 1% in terms of the number of citations they
collected. We can see that actually Australia is producing doing quite well in this perspective with 4.36 of its publications are in the top 10, in the top 1% of the field. So let's see, okay, let's have a look now on phosphate-related research, but with environmental sciences. Also, China is leading here, as it's clear, by 6,503 publications in the last 10 years. The USA comes second here. This is, again, a quantity indicator. If you go to quality, we can see that Australia is doing pretty good, 1.51 CNCI impact. And then also Australia is doing good in the percentage of highly cited papers. It means that Australia, though it's only number 7 in terms of the nations producing phosphate-related research, the quality of research done in Australia is quite good. Actually, it's impressive in this approach, environmental approaches. Now we go to geological sciences. I think mining and geology, it fits here. Not I think, I believe, actually. So we go with USA now leading, actually exceeding China. With USA producing actually a double number as compared to China with around more than 1,800 publications in the last year, followed by China, etc. If you go to the quality indicator, France has a CNCI, category normalized citation impact, of 1.53, quite well, actually. You can see the highly cited paper, actually, United Kingdom is doing actually also good in the geological sciences approaches. What about chemistry, material science? So if you are a researcher doing research on phosphate and doing material sciences like chemistry approaches or so you need to look at this. China is leading again with more than 10,000 publications, followed by the US. Speaking about impact, actually, USA and Germany have an equal score of 1.26. It means that exceeding the world average by 26%. And concerning the highly cited papers, we can see that the USA has more than 4% of its papers ranked as highly cited paper. It means like top 1% of the publications. So looking a bit about the dynamics, how it's evolving by time. Of course, we know that China and USA are leading, actually. So this is in 2008, and this is our environmental approaches to phosphate-related research. We can see that in 2008, China started here, while the USA started here. What happened in 2011, you can see that China actually is outperforming the States, and it's keeping, now it's #1 in terms of annual research output in environmental approaches for research related to phosphate. The other countries are not doing as well in terms of the quantity, of course. So you can see who is actually governing the world of environmental approaches of phosphate-related research. So let's have another look on the geology approaches to phosphate-related research. Who is actually doing well? How is it evolving? What are the dynamics of the nations doing research on mining and all aspects related to geology in regard to phosphate? You can see here also, this is the USA, this is China. So USA was leading and is still leading. What happened here that China in 2015, somehow, the output dropped actually, and until 2017, it was dropping, and it's clear that the US is leading actually by some margin there. Of course, this is only one indicator. If you want really to give an advice, if you want really to be a good consultant in this concern, you have to look at other indicators and really make a judgment. But this is a numerical value which is pretty well sharp and clear. So top 10 research entities. Now we move to research entities. These research entities can be universities or even like
Max Planck Institute itself is not a university, it's a research entity, sole research entity, or R&D department as well. So top 10 entities in terms of the number of publications, we can see the Chinese Academy of Science leading by more than 1,650 publications, followed by United States Department of Agriculture, etc. These are the top 10. But this is also, this is a quantity indicator. What about the quality of research coming out from those entities? So you can see that the Chinese Academy of Science, while being the leader in terms of the research output, the impact is 1.46, which is quite good. It means that it's beating the universal average by 46%. While if you want to see that, we have a look at CNRC, it's 1.88, one of the best in the world in terms of these approaches to phosphate related, the impact. Also, University of California system doing pretty well. Also, INRA, which is a French Institut National de la Recherche Agronomique, somehow like this. Okay, so moving to patents. So the x-axis here is the year at which the patents are actually issued themselves. And the y-axis is the number of patents. This drop actually is nothing but because when you file a patent, you need to wait basically for 1.5 years until it's issued or granted or so. This is the cause, the reason of this drop. But overall, we can see that the number of patents is increasing in a yearly basis. It means that research output in terms of publications and patents are going hand by hand. So people are interested in phosphate in terms of publishing it in articles, in journals, but also in patent it. This is the way to go in a lot of cases if you want to complete the life cycle of innovation and get a potential economic value out of it. Nations are still really highly interested in it, as this curve can show us. This curve, this is like a pie chart. Because of the Chinese, it's not a like pie chart anymore, because they are like really filing more than 90% of the patents related to phosphate, but with agriculture approaches. This is really an impressive number. I don't have the chart here, but there's a chart showing the number of patents filing by Chinese starting from 1995. It's really going like a rocket. So somehow they moved from sole publications to go really and file patents. Sometimes actually slowed a bit with the publication process and start filing instead patents. So I end up with a couple of slides on the Moroccan research on phosphate. So these are the top 10. First, I want to clarify something. When we say Moroccan research, we are talking about Moroccan affiliated research institutes. It means that if we have a research entity, it can be like French, like CNRS, but we have a lot of Moroccan working there. We have some Moroccan universities also collaborating with them. So this is counted as Moroccan affiliated because basically it's partly Moroccan also because we have Moroccan researchers there. You can see that CNRS is leading in terms of Web of Science document by the last 10 years, 226 actually publication, followed by Mohammed V University by 156. So this is looking at the quantity here. What about looking at the impact, CNCI? You can see that Sorbonne University and the work affiliated with Sorbonne University had the better impact with 1.19, which is beating the average score or impact by 19%. If we move to the percentage of documents in a Q1 journal, what do we mean by Q1 journals? So journals which are receiving impact factor by us. So we categorize them into 4 quartiles. So Q1 is top 25%, as simple as this. So publishing more in Q1 journal, it's an indicator, it's a quality indicator, as we can see. So you can see that also Sorbonne University has around 55% of its publications in Q1 journal. This is also a quality indicator. You can see also that the CNCI and the percentage of documents published in Q1 journals, they are really correlated to a large extent. So what about the top 10 collaborators of the phosphate-related research? So when Moroccan affiliated researchers want to do phosphate research, what are the collaborators usually? Of course, France comes first with 347 publications, and then comes Spain, etc., Germany, etc. This is the number of publications. What about the impact of these publications? So France has an impact overall. I'm talking only about research related to phosphate, which is in the context of a collaboration between France and Morocco. It has an average impact of 1. So basically, it's the word average. It's set by this collaboration. While if we look at another collaboration, you can see here that when Moroccan affiliated researchers collaborate with organization affiliated with Canada, they get impact 1.95. Quite, I mean, almost double the universal average. Also with the States, 1.91. Also with Tunisia, 1.5. So this is also only an indicator saying that the research in the context of those 3 collaborators is doing better in terms of impact. Of course, I have to repeat, this is only one indicator. We really have to see a set of indicators, and this does not rule out the human judgment on the collaboration itself. So what about the top 10 funders of the phosphate-related research produced with Moroccan affiliated? We can see CNRS coming first, and then European Union, etc. Those are the funders, top funders of phosphate-related research. This is basically like a summary of like Moroccan phosphate research profile, so to say. What's showing on the x-axis is the category normalized citation impact. This is the impact, CNCI. On the y-axis, it's showing the percentage of international collaboration. It means if we pick like this university has 60%, almost 60% of its work in phosphate we are working, has international, whatever this international collaboration, and has an impact of 0.6. I think it's clear now. We can draw easily, with some small exceptions here and here, we can draw easily a straight line here, almost linear relation. It means that as the percentage of international collaboration goes up, the impact goes also up. It's linear. Of course, this is only an advice. In this context, we need more indicators to be really adopting a more broad and general approach. But basically, this is showing us this result here. It's like better category normalized citation impact is leaving your research with bigger impact because of partly because you are having more international collaboration with your research in phosphate. So with the conclusions and outlet, I will just would point out that there is a consistent annual growth in the research related to phosphate. I would also point out that China and USA are leading. Moroccan phosphate research output is also growing in annual basis. And the fourth conclusion would be phosphate-related research, Moroccan one actually, with international collaboration somehow yielded better impact. I would thank my team members here who helped me actually to get the data out. And thank you for your attention.
Thank Thank you very, very much for this, presentation with a lot of numbers. And the key message that I retained from your presentation, which is really very important, is that you have clear correlation between economy and research. And thank you very much.
Thank you.
And I think we can take some questions here. Yeah. Any question?
Can anyone hand the mic there?
Thank you very much, Mr. Chairman. Thank you very much for this nice talk, enlightening all Moroccan present here. And what would you advise for OCP and for Moroccan research and researchers?
This is a very important, but still very broad question. Still, it's important. I think the idea of my talk, just to give a glimpse, an idea, to touch something that we can evaluate our work, we can actually anticipate and study the landscape of research related to phosphate from different angles. We can take action based on numbers and indicators. This is the key message. How to take action? I think this is a really complex, but still very smart and sharp consulting work, which can be easily done while we have such indicators. The key message, I think, what I've said, plus international collaboration actually is helping. Now, if you ask us where to go in this realm, what to do now, in which actually research area to invest more, to put more resources, this can be easily done. I mean, this is what we have been doing with the governments worldwide. I mean, I'm working now with the MENA region, but I was in the context of Max Planck actually Institute in Munich. There's a lot of collaboration worldwide. In Spain, in Italy, we have been doing the same. And we are pleased to do this in the MENA region. But what can I assure you that it's a lot can be done, and we have a lot of successful stories.
Thank you very much. But I think also from the last plot you have made, when you see increase of the impact factor, impact of research, as a matter of fact, and that means also the hope for increase of product of business. Because as long as you increase, the impact publications, you increase also the welfare of the society.
Exactly. This is the ultimate translation of the thing.
And when I make extrapolation, maybe, of course, Ayman, I don't know, from Morocco, from somewhere not far from Morocco, but with the relation between France and China and Morocco are long, deep, diverse, and concern all domains. But maybe Morocco should take step also to make a kind of approach with China.
Exactly, yeah. You pointed out. So this is like something like, this is the elephant in the room. So Chinese are there, and they're doing really great work. So, yeah.
Okay, I think we should move on to another question.
Thanks a lot.
Any other question? I have two, actually, myself. One is related to your presentation. One is not related, but it's related to ranking.
Please, go ahead.
The first one is curiosity. Why in your indicator, the number of paper, why you don't divide it by the number of population, for example?
So, I mean, if you need, not number of population. Some people are suggesting that we divide it by the number of staff, by the number of researchers in the institute, which makes sense for some ranking systems, university ranking system. But for us, or for me as a researcher, if I am working in OCP or Mohammed VI University or so, I really want to work with a university which have a lot of research output, a lot of publications in this realm. I'm sure it's not fair to compare universities because those have a lot of resources and others they don't.
But as a researcher, I need something which could work. So I could go for large output, large volume of publications. This is what matters in terms of decision makers to study, to scout the expertise in the world. But the kind of indicator you are suggesting, it's already there in the ranking system.
Okay, now regarding the ranking system.
Yeah.
We have many kind of ranking, Times, Shanghai, and many others.
Yeah.
I believe that those way of ranking, especially African countries, somehow are not adequate. Can we imagine to introduce new way of doing, to create new indicator for African universities?
Great question, actually. Like just last week, we had a workshop and a lot of presentation on this topic exactly. I mean, the thing is, we have ranking systems. We can go either ways. Either we adapt ourselves to be better in the eyes of this ranking system or that, or we do our own ranking. I guess, I wouldn't advise exactly on this, but what I want to say, that ultimately, if I want to be better ranked, I have to ask myself the question beyond this. What's the idea of being better ranked? I want to be better in research. Like, I'm taking only this one. Someone might say, okay, I want to be better in research. Another guy would say, no, I want to be better as a teacher. So if I want to be better in research, what ranking system has a better research dose, so to say? There are answers to this.
Absolutely.
Some ranking systems, they have like 80% of their criteria are taken from research. So basically, if I am ranked better in this ranking system, it means it reflects to my research profile. Some ranking systems, they depend basically around 45% on what they call reputation survey. Reputation survey works great with Harvard, with Max Planck, with Stanford, Cambridge, etc. But what about our universities in the MENA region? It doesn't work well. And it also reflects, it means if I am a university, I am a good university based here, but I don't have such a great marketing budget. It wouldn't work for me. So basically, if you are comparing universities based on reputation survey, it means that you are comparing partly universities based on their marketing budgets. Whatever you do, you will lose if we are comparing you with some university, average university in the Gulf, to be honest. You will lose. So it means you have to wisely choose your ranking system or systems. We have some, actually we helped some governments, I wouldn't name it here, we're not allowed, to actually build their ranking system. But what they did actually, it's not like they built their own entirely independent ranking system, no. They actually did some averaging of pick 3 or 4 ranking system, and they give every rank of them a weightage, and then they ended up averaging the 4 ranking system. This is a way to go. What I want to add on top of this really great question and on the point, that it's not about ranking, it's about what do we want. If we want to be better in research in this domain, we have to develop not an evaluation indicator, evaluation strategy. It's built on indicators plus other items.
But we still need to have the right parameter weighted at the right things in order to have, this, I call it Ben Greer ranking, like Shanghai ranking or something like that.
Exactly. Exactly. Plus, I want to add last thing. If I am a freshly graduated student from a school, I want to go to university, I wouldn't look at some ranking system giving only like 15% to the teaching criteria. I would go for ranking systems giving around 30, one of the ranking system without naming them, it gives around 37.5% only to the quality of teaching, plus some criteria learning experience. This ranking system is relevant to students searching for a right school to start their education, but it's irrelevant for an institution seeking research to find potential good and smart collaborators, because it's relevant to teaching, not research.
I think perhaps we can take last question from lady. We cannot say no. Please.
Can anyone hand in actually the microphone?
Yeah, the last one, question.
Thank you. I have two questions, actually. The first one is, how do you evaluate the impact of research? Is it by the percentage of the patent that is turned into commercialized projects? And the second one, do you have an idea on what is the percentage of these patents that are used or commercialized in Morocco or by Moroccan or in Moroccan phosphate industry? Thank you.
Yeah, great. Thanks a lot. Concerning the first question, what I did with the impact thing, I didn't do it on patents, I did it on research. The way we basically, it's overwide accepted by, in general, by the research community to evaluate research or to evaluate the impact of research to link it by citations. You mean even in Germany, in France, they are taking into consideration the kind of journals and impact factor receiving by the journal. So if you are publishing with journal with high impact factor, it means that you are leaving better impact. Coming back to your question, we are relating everything to, I mean, this is relating everything to citation analysis, but this is only an indicator. It needs a decision maker to make a wise decision based on indicators and other parameters, which are really customized. For the patent things, it's doable. I mean, we already have IP management systems. We have Derwent Innovation actually scouting the same way I use Web of Science to work with publications, articles, reviews, peer-reviewed. Of course, we can work with patents. But for this talk, it's really so short and so specialized about phosphate to point out every aspect. This is only to see what can be done and what, to be honest, need to be done. But thank you for your question. The commercializing part, I didn't present it. We have something which is similar to what you want to actually ask about. It's about if you have a patent, you need to know how to manage this patent. Is this patent still alive? Are we paying the yearly fees? Is it already in the public domain, etc. So a lot of information, we need to have access on it. But just one last comment. The decision to publish something or to publish it in an article or to file it in a patent is really a costly decision either way, and it needs to be done. And for this, you need to have the right tool actually to make informed decisions on this.
Thank you very, very much. I mean, let's thank our plenary lecturer, Dr. Akil. Thank you very much. Thanks a lot. Thank you. Thank you. Right now, we switch to the second part. And I have, first, I have to ask the jury members, please, to come and to sit in the first row. The jury members are Yassine Biaz, Khalid Baddou, Tina Liberto, Hélène Peterson, Rachid Jauhari, Julia Diaz, Mohammed Aitbabram, and myself. Please sit in the front. And we are going to start the oral competition of young researchers. Before we start, I will tell you how it will work. The jury member, we have, actually, I'm sorry. The competition started actually with 70 PhD students. From those numbers, 24 were chosen this weekend to go through very tough competition and very tough presentations. Among 24 presentations, the jury members have chosen 6 of them, which are here today. Please relax. You are among friends here. Please relax. Okay? Now from the 6, we have to choose 3 people. And how these 3 people will be chosen? 2 will be chosen by the member of the jury. And the 3rd one will be chosen by your vote. And somebody is going to distribute some card, and please vote for only one person, just one. If you vote for 2, your ticket or whatever will be canceled. Just one. And of course, if the one that it will be chosen by the member, by the public, by you, will be already chosen by the jury member, we will go for the 2nd one. Okay? Is it clear? And please encourage them, and remember your first presentation and how was it? Remember it. And they're really very brave to be here in front of you, and please welcome them, and we will go through some list that I have here. And the first candidate will be Mohammed Likhal Sanhaji, and everyone has to give presentation in maximum in 5 minutes, not more. The floor is yours.
Start. Hello, everyone. Actually, I'm here today for only one purpose, is to talk about a famous common problem in fertilizer company, is the cake intensity. So, as you know, the granular fertilizer production presents some problems, especially the family of ternary fertilizer. Agglomeration, or the cake intensity, is the ones that affect the physical quality of granules and they make them unsuitable for their intended uses. This can create several difficulties, like blocking the fertilizer distributors, which is huge, a big problem for farmers, and also for producers. It affects the free flowability of fertilizer during storage and transport, and no one thought just one transported fertilizer ship contains about 30,000 tons of fertilizer. Yeah, 30,000 tons. So you can imagine, you can expect the extra cost that we need to recycle this caked fertilizer. So the main objective of our project is to recycle new anti-caking agent capable to reduce the cake intensity of fertilizer and ensure the free flowability of granules using natural products. So what is an anti-caking agent? Actually, anti-caking agents are all substances that we add to the outer surface of fertilizer in order to coat them, protect them, and prevent their agglomeration. For that, we use the experimental design methodology as a powerful tool to organize, control, and evaluate the effect of several products as an anti-caking agent. So from Pareto chart, we notice that only the 4 first products present significant effect on the cake intensity. And according to the effect graph, only the last one, sodium carbonate and silicon dioxide, present a maximal positive effect, which means more we use them as an anti-caking agent, more the cake intensity increases and the coating is not good. It's the opposite for glycerol and calcium carbonate. More we use them, more the coating or the coating agent is effective. So for that, we selected glycerol, calcium carbonate, and molasses to formulate different formulation using mixture experimental methodology. So from the ternary diagram, or the ternary diagram indicate that the cake intensity of granules decrease moving from the lower corner of the diagram to the top, which means there are an infinity of compositions that give a low cake intensity, including those that contain only the glycerol. Think that pushed us to think and to agree about developing new anti-caking agent based on glycerol and other surfactants using natural product or natural abundant product like oils and fats. Of course, everyone knows oil and fat, so we can valorize them to formulate the category of liquid anti-caking agents which are used as pulverizing coating. So our idea is to synthesize our own anti-caking agents based on trans-esterification reaction of oil and fats in presence of methanol. So we obtain two products as raw materials. So we have glycerol and methyl ester capable, or from these two products, we can formulate different reagents, different composition capable to reduce the cake intensity of granules and ensure their flowability from producer to the farmer. And I mean by that, from storage, transport, until handling. Thank you.
Excellent, Mohammed. Thank you very, very much. Thank you. Congratulations. And the second candidate will be Kautar Khawla Kaltouma.
Phosphate researcher, allow me to present to you two important elements for our agriculture: water and phosphorus. Phosphorus is an essential element for our planet, for our agriculture production. And it is one of the major elements that limiting plant growth. However, these elements and a portion of this inorganic phosphate and the mineral phosphate that we apply to the agriculture as a fertilizer, it interacts with many different elements in the soils and it remains in insoluble forms, which means that it interacts with different elements like aluminum, iron, and or calcium. And so it becomes unavailable to the plant, and the plant can't make benefit from a high percentage of phosphorus fertilizer that we apply to the soil. So let's move now to the second element, which is water. You all know that without water, we can't live. There is no life, no agriculture production without water. But this resource is under high pressure because first of the increase in demand due to demographic growth and change in food diets. And secondly, because of the decrease in availability due to climate change. And when we talk about climate change, there is a decrease of precipitation and also the increase of the temperature. And when we talk about also the increase of temperature, there is an increase of water evaporation from the surface soil and also from the plants. So what is the problem now? The problem is that our soils are under deficit water and deficit conditions of phosphorus. There is many study on the effect of phosphorus deficit, phosphorus limitation, and also water deficit and water scarcity. But there is a lack of information on their combined effects on plant production, on their agrophysiological response. So our aim is to study the combined effect of water deficit and phosphorus deficiency on plant growth, nutrient uptake, and their agrophysiological response. To do so, we set up experimentation under greenhouse conditions, which mean that we have the capacity, the possibility to control water and phosphorus application. And we try to test the response of 4 faba bean varieties: Aguadulus, Alfia, Luz d'Otoño, and Reina Mora, to different level of phosphorus deficiency, sufficient conditions, and stressed conditions, and also to different level of water, sufficient conditions, and deficit conditions. And we try to observe how could plant respond to these stressed conditions while maintaining a high and good production, high yield, high nutrient content, because as you know, faba bean is very known for its protein content and nutrient content. And so we try to study this effect, these stressed conditions on our plants. And the results revealed that there was a significant effect of water deficit and phosphorus deficiency, either alone or combined or on our plants, and its production, its agrophysiological response, and also mini nutrient accumulation. And the different variety have responded differently to these stressed conditions. And also we find that phosphorus content, it's varied when there is a stressed water conditions or sufficient water conditions. To conclude, water and phosphorus are non-renewable resources, so they are very important for our production. So our challenge is how to produce more with less water and fertilizer inputs. One of the solutions is to make profit of or to explore the potential also of soil organism, and this for a sustainable biotechnology, a sustainable agriculture. And thank you.
On time. Thank you very much, Colin. Good.
Thank you.
Okay, the third candidate is Safar Mabrook. Let's welcome her.
Good afternoon, everyone. Firstly, I would like to thank the honored audience for their presence today, and also I would like to thank the committee for giving me the chance to present my project. I would like to ask you a question. Can you imagine a house totally and fully constructed by wastes? Well, that's what my research team is aiming to do. As a member of the team working on the valorization of phosphate byproducts to produce construction materials such as concrete, cement, and bricks, I wanted to do something different, something new, something creative. So I imagined that I would like to build a house, and I have all of the materials I need. I have concrete, bricks, and cement. But something is missing, something important is missing. In the same time, I have a problem with broken tiles in my home. Then I thought, why not finishing construction materials from phosphate waste rocks? Let me first give you an idea about the quantity of phosphate waste rocks generated in my country. Today, we are talking about millions of tons of phosphate waste rocks stored and deposited on a large surface reaching 30,000 hectares. This kind of wastes has a negative environmental impact, such as reducing arable lands, modifying topography, and disfiguring landscapes. It also represents a huge issue in terms of storage capacities and rehabilitation. So, my solution involves an innovative process consisting on sampling rocks from intercalation, mixing them with additives such as binders and pigments to elaborate eco-friendly and ecological tiles and artificial stones. Our products are similar to those existing in the market in terms of physical and mechanical properties, following Moroccan and European standards. Also, our products are ecological and eco-friendly because they're produced from zero CO2 emissions and low energy consumption. And finally, our products are going to be expensive because our raw materials are free. We are using phosphate waste rocks. So it's going to make them more competitive in the market. Imagine that 1 ton of phosphate waste rocks can produce 74 meter cube of tiles and artificial stones that we can sell with 500 dirhams per meter cube. We can imagine the benefit. Our solution will not only create new jobs and develop the economy, but also can give to the phosphate regions a new architectural identity, such as Notre-Dame de l'Assomption Cathedral in Clermont-Ferrand, which is totally and fully constructed by region stones named Vilvac stones. Finally, and it's the most important point, the aim of my project is to produce and extract phosphate with zero waste rocks and implement the circular economy not only for water and energy, but also for recycling waste to create new resources. Now, I can say that I will build my house only with wastes, and it's going to be ecological. Thank you for your attention.
Thank you, Safar Mabrook. I will build my house also with your time, if you allow me to do so. Thank you very much. Congratulations.
Thank you.
The fourth candidate is Hamza Briak. Let's encourage him too.
Bonjour tout le monde. Nous ne le remarquons pas. Nous marchons dessus, le frôlons aux pieds tous les jours. Pourtant, nous avons besoin de lui, comme l'air que nous respirons. Il est grand temps de parler du sol, grand temps de le protéger. Sans lui, il n'y a pas de vie, il nous nourrit et nous sommes responsables pour lui. Le sol résulte de la dégradation progressive des roches sous l'action du soleil, du vent et de la pluie, des animaux et des plantes. C'est ainsi qu'en 2000 ans se crée une couche de 10 cm de sol fertile, 10 cm seulement en 2 millénaires. Un sol que nous épuisons en quelques années, perdu à jamais. Les forêts et les plantes protègent le sol. Chaque année pourtant, 13 millions d'hectares de forêts sont défrichés et les champs exploités de façon inadéquate. À ça s'ajoutent les monocultures et l'exploitation des versants. Après les récoltes, le sol reste nu, sans protection. Cela accélère considérablement l'érosion. 24 milliards de sols fertiles dissipés par le vent, emportés par les pluies, rien qu'en 2015, une perte de 3,4 tonnes par personne, toutes âges confondus. Dans ce contexte, et pour faire face à tous ces problèmes, on devrait d'abord comprendre comment et par quoi sont régis les fonctionnements hydrologiques d'un bassin versant et quels sont les principaux facteurs qui régissent la dégradation des sols afin d'estimer les sites dégradés et d'évaluer les pertes de l'eau, de sédiments et de nutriments. Tout cela peut être analysé grâce à la modélisation. Donc la présente étude est basée sur un bassin versant. La présente étude est basée sur un bassin versant méditerranéen. Pourquoi ce bassin versant exactement? Parce qu'il se caractérise par une forte humidité, différentes classes de pentes, différents types de sols, et le plus important, c'est que 64% de la terre est occupée par les terres agricoles. Tout cela influence considérablement l'érosion. Et quant à la modélisation, mon choix a porté sur un modèle américain, agrohydrologique, bien développé mathématiquement et informatiquement par l'USDA, United States Department of Agriculture, appelé SWAT, Soil and Water Assessment Tool. Ce modèle permet de simuler les principaux processus d'un bassin versant, n'importe quelle surface, telle que l'hydrologie, la sédimentation, le transfert d'éléments nutritifs, l'environnement et le changement climatique.
Donc, l'application de ce bassin est basée sur deux grandes étapes. La première est la mise en œuvre du modèle, qui nécessite la présence des données météorologiques, hydrographiques, de données d'occupation des sols et de données pédologiques. Cette étape nous a permis d'exécuter le modèle. Après, on passe à la deuxième étape, qui est la calibration et la validation du modèle, qui a été effectuée sur 18 ans, 9 ans pour la phase de la calibration et autres 9 ans pour la phase de la validation. Cette étape nécessite la présence des résultats mesurés sur le terrain, des débits et des concentrations des sédiments, afin de les comparer avec les résultats simulés par le modèle pour les ajuster et les rapprocher vers la réalité. Et d'après les résultats de mon projet, on peut dire que le modèle a été correctement calibré et validé sur le bassin d'étude en comparant les débits mesurés à des débits simulés et des concentrations de sédiments mesurés à des concentrations de sédiments mesurés. Les courbes en rouge représentent les données mesurées sur le terrain et les courbes en bleu représentent les données simulées par le modèle. Et ce qui est approuvé par les différents calculs de différentes coefficients statistiques et qui nous a permis d'obtenir une très bonne performance du modèle pour la phase de la calibration et aussi pour la phase de la validation. Alors on constate que les différentes étapes de la configuration des modèles ont poussé soit à refléter les conditions réelles autant que possible, le cycle de l'eau, les sédiments, les nutriments, etc. En effet, le modèle nous a permis à prédire avec succès les différentes composantes du cycle hydrologique, telles que l'évaporation, le ruissellement, la percolation, l'infiltration, etc. dont 43% des précipitations sont transformées en évaporation et 35% des précipitations sont transformées en ruissellement. Ainsi, la production des sédiments érodés et acheminés vers la balle a été estimée avec succès par le modèle et la quantité fournie s'avère très élevée, 54 tonnes par hectare par an. En plus, le modèle nous a permis de prédire le transfert d'éléments nutritifs tels que les nitrates et le phosphore, et les valeurs représentées sont très importantes et non négligeables, telles que 33 tonnes par an pour les nitrates et 15 tonnes par an pour les phosphores. Alors on peut dire que sans doute toutes ces pertes sont dues à l'influence de l'agriculture traditionnelle sur l'érosion, parce que les pratiques du labour augmentent les pertes des sédiments et des nutriments. Et à la fin, on peut dire que ce modèle contribue à la gestion des ressources en eau, en sol et en sédiments, et qui est très utile pour les décideurs locaux, afin qu'ils puissent proposer des aménagements efficaces pour réduire les pertes et par la suite protéger notre sol, notre environnement, ce qui est favorable pour le développement durable de notre pays. Et merci pour votre attention.
On time. Thank you very much, Hamza. Thank you. Congratulations.
Merci.
The fifth candidate is Asma Al-Agri. The floor is yours.
Hello. How many of you love the sea? I think everyone, especially in summer, to do surfing, sailing, swimming, or maybe just relaxing in the sea shower in the evening at the sunset. What a beautiful and colorful view. But imagine with me that your amazing sea is polluted, not by garbage, plastic, or by oil from the boat, but white residue, named phosphogypsum. What a trouble. You know, phosphogypsum is a byproduct generated by the phosphate industry and is produced during manufacturing phosphoric acid from phosphate rock. Nevertheless, this product menaces the environment because it is generally deposited and stored into the sea. You know how much ton of phosphogypsum generated during the production of phosphoric acid? So what do you suggest? 1 ton? 2? Referring to some research published recently in this file, 4 to 6 tons of phosphogypsum are produced for each ton of phosphorus oxide. So this huge quantity constitutes a risk and make a challenge for the phosphate industry. Nevertheless, in Morocco, 15 million tons of phosphogypsum are produced each year and thrown into the sea. And as a result, the environment is severely hampered. To face this situation, and as I'm a PhD student, I thought of a solution for a better and safe management of this residual. My proposition consists to extract sulfur from phosphogypsum and to use it after for manufacturing mineral fertilizer. Do you know why I'm focused especially to extract sulfur elements? Because on the first hand, this nutrient is one of the second elements in fertilizer and is used for many reasons. For example, for plant chlorophyll formation, help crops resist to disease, and aids in growth and seed formation. On the second hand, phosphogypsum is a matrix rich in sulfur. According to some research published recently in this field, phosphogypsum contains approximately 50 or sometimes more than 50% in phosphogypsum. So this resource, enriched on this yellow gold, does not deserve to be thrown away immediately. On the contrary, phosphogypsum should be managed and evaluated. Especially that sulfur market was highly volatile recently, and the extent and velocity of the fly-up caught most market players by surprise. Depending to some research, the extraction of sulfur from phosphogypsum can be done with two different approaches, biological approach and chemical approach. For the first one, sulfur is extracted by biodegradation of sulfate reducing bacteria in order to obtain hydrogen sulfide and subsequently sulfur. The second approach consists to breaking down phosphogypsum into calcium oxide and sulfur dioxide through a sequence of some reaction. Calcium oxide could be mixed with another matrix in order to use it after for manufacturing other materials, like for example, cement and bricks. Sulfur dioxide could be used for manufacturing sulfuric acid and by the end, sulfur matrix, which constitutes our objective. The process of extracting sulfur from phosphogypsum exists for the moment, but the operating conditions of this process are long and energy consuming. For all these reasons, we are looking by this project to facilitate the process of the decomposition of phosphogypsum and optimization of sulfur recovery conditions. The rejection of phosphogypsum into the sea without any treatment not only harasses the environment and the human health because of impurity it contains, but also an economic loss. By a better valorization of this residue, you can spend your holidays and enjoy your time with your family into the sea with all comfort and security. And thank you.
Thank you very much. And as usually, the last but not the least presentation will be done by Ikram Labtani. The floor is yours.
Environment without dust, and adequate industrial working conditions, and an efficient filtration system. All these aspects together became possible with the system of pulse jet baghouse dust collector. So, this is the context of my thesis entitled Study of the Pulse Jet Cleaning of Baghouse Dust Collector in UM6P group to improve the filtration performance and pneumatic cleaning optimization. So in UM6P group, baghouse dust collectors are used to reduce the rate dust emissions and to comply with the air emission standards. But how? So baghouse dust collectors are used to filter the phosphate dust-laden air. However, the aim of my thesis is to examine all components and factors that affect the performance of the baghouse dust collector, and also to contribute to a better understanding of the consequences of the pulse jet cleaning baghouse dust collector. For this purpose, 2 research fields were investigated: an experimental approach and the numerical approach. So the experimental approach was divided into 2 parts. The first part concerns the filter characterization, as it is considered as the hope of the baghouse dust collector. And the second part concerns the phosphate dust characterization, as it is the filtered elements. And for the numerical approach, I opted for the computational fluid dynamic based on the Navier-Stokes equations to predict the fluid flow behavior inside the filter bag. So here, the originality of this work is that the samples are taken from an industrial baghouse dust collector. As for the numerical approach, the model developed was adapted to simulate the fluid flow behavior inside an industrial filter bag. So as a result, both characterization of the fibrous filter and phosphate dust led to a new result for improving the filtration system and optimizing the pulse jet cleaning. So here, sorry, I can't show you all the results because I got a lot of results, but here is an example of the scanning electron microscope measurements applied on a new filter media, which enabled to determine the wall thickness of the fibrous filter media. As for the phosphate dust characterization, the scanning electron microscope measurements gave access to several information about the morphological characterization of the particles. And for the first time, an element mapping was applied on untreated phosphate dust to provide useful information on the spatial distribution of the phosphate elements. As for the numerical approach, sorry. As for the numerical approach, a simplified 2-dimension model was developed to predict the fluid flow behavior inside the filter bag in terms of velocity, pressure, and temperature. Unfortunately, the model was validated by comparing our work to those already existing in the literature. Finally, this work focuses on the study of the pulse jet cleaning industrial baghouse dust collector, and the finding of this work may find application in the drying unit phosphate industry, where baghouses are commonly used. And thank you all for your attention and for your attendance.
Thank you. I'm sure that you have noticed that they did extremely well job. And the competition will be very tough. And for me, the 6 of them did really good job, and it will be very, very difficult to separate between these presentations. I must recognize something. When I was doing my PhD, and the first presentation that I was doing, at that time, they were much, much, much lower in quality that we have heard here. Really much lower, day and night. Thank you very, very much. You did really wonderful work. Behind the scene, you have a lot of work. And let's also thank the organizing committee who did really wonderful work. As I said at the beginning, we started from 70, and we are going to 6 or 3 candidates. It's very, very good work. Thank you very much for organizing committee. Actually, the winners will be announced during the gala dinner, okay? And we need your vote, and when you are exiting the door, please, you find somebody who will take care of your vote. That's how, okay. Just at the outside, you will find people that please give them your vote, and it will be very, very important for the third person that we are going to choose. Okay, I think we are going to close this session, but before that, of course, after this plenary session, we have parallel sessions which are going to start very soon. And please be back around 6:30 for best poster and for closing ceremony. And thank you very much and have a good afternoon.